Imagine standing on a dusty plain under a salmon-pink sky, with the sun appearing just a bit smaller than it does from Earth. Beneath your feet, the ground is rich with iron oxide, giving everything a reddish hue. This isn't a scene from a science fiction novel, it's a glimpse into what life on Mars could be like, a frontier that many believe is humanity's best option for colonizing another world. Mars captivates our imagination for several reasons. First, its day is remarkably similar to Earth's, lasting just over 24.5 hours. This means our circadian rhythms wouldn't need drastic adjustments, making it easier for humans to adapt. Moreover, Mars has polar ice caps composed of water ice and dry ice, which is frozen carbon dioxide. The presence of water ice is a game changer. It can be used not only for drinking, but also broken down into hydrogen and oxygen for fuel and breathable air. Consider the thin Martian atmosphere, composed mostly of carbon dioxide. While this poses challenges, like insufficient protection from solar radiation, it also offers opportunities. Plants could potentially be grown in controlled environments, utilizing the abundant CO2 for photosynthesis to produce oxygen and food. Technologies like domed habitats or underground living spaces could shield settlers from radiation and extreme temperatures, which can range from a balmy 70 degrees Fahrenheit near the equator to a chilling -125 degrees Fahrenheit at the poles. Now let's contrast this with Venus. At first glance, Venus seems promising due to its Earth-like size and gravity. But you know, appearances can be deceiving. The surface temperature is hot enough to melt lead, and the atmospheric pressure is crushing, about 92 times that of Earth's at sea level. The air is thick with carbon dioxide, and clouds of sulfuric acid loom above. While some visionary concepts propose floating cities high in Venus's atmosphere, where conditions are less extreme, the technological hurdles are monumental compared to those on Mars. Europa, one of Jupiter's moons, entices scientists with its subsurface ocean beneath a thick layer of ice. The idea of an ocean world teeming with life is thrilling. However, Europa is bombarded by intense radiation from Jupiter's magnetosphere, and the surface temperatures are brutally cold. Accessing the ocean would require drilling through miles of ice, a feat far beyond our current capabilities. The environment is so hostile that sustaining human life there would be an extraordinary challenge. Then there's Titan, Saturn's largest moon, enveloped in a thick, nitrogen-rich atmosphere. It's the only other place in the solar system with stable liquids on its surface, though these are lakes of methane and ethane, not water. The concept of sailing on liquid methane seas is fascinating, but Titan's frigid temperatures hover around -290 degrees Fahrenheit or -179 degrees Celsius. While its atmospheric pressure is similar to Earth's, the extreme cold and lack of oxygen make it an inhospitable option without significant technological advancements. Returning to Mars, it's not without its own set of challenges. The thin atmosphere provides little protection from meteoroids and radiation. Dust storms can engulf the entire planet, lasting for weeks or even months. But these are obstacles that seem surmountable with concerted effort and innovation. For instance, building habitats underground or using three-dimensional printed structures made from Martian soil could offer protection from the elements. Imagine robotic missions paving the way, setting up habitats and preparing the infrastructure before humans arrive. Solar panels could harness the sunlight for energy and perchlorate compounds in the soil, while toxic could potentially be processed and used in manufacturing or as rocket fuel components. With the right resources and determination, Mars could become a second home. In comparison, the extreme conditions on Venus, Europa, and Titan present far more significant barriers to colonization. Venus's surface is a pressure cooker. Europa is locked under ice and radiation. Titan is a deep freeze. Mars offers a middle ground, a place that's challenging but not insurmountable. So, when we weigh our options, Mars emerges as the most feasible destination for human colonization, based on our current knowledge and technology. Its relative proximity to Earth reduces travel time and communication delays. The potential for in-situ resource utilization using Martian materials to support human life makes long-term settlement a tangible possibility. In essence, Mars is the canvas upon which we can paint the next chapter of human exploration. It's a place where we can test the limits of our ingenuity, adapt to new environments, and perhaps discover new facets of what it means to be human. As we stand on the cusp of this new era, the red planet isn't just a distant world orbiting the sun. It's a beacon calling us to reach beyond our home planet and expand the horizons of our existence.